Hello children, today we are going to study the real numbers and their decimal expansions. Now you see, last class you got the concept of real numbers. Real numbers consisting of two parts. The two opposite parts combining real numbers. One part is called rational numbers and another opposite to rational number it is called irrational numbers. The last class you have got a definition of rational numbers and irrational numbers, and rational numbers and irrational numbers together they form the real numbers. So today also we'll study rational numbers and irrational numbers from a different point of view. So we'll study rational numbers and irrational numbers in terms of their decimal expansions. So first we'll study the decimal expansions of rational numbers. So see, rational numbers have two types of decimal expansions or two types of decimal representation. When we get decimals of rational numbers, when we divide the numerator by the denominator, then only we get the decimals. So always we get two types of decimals when we divide the numerator by the denominator for any rational numbers. Your first type of decimal expansion is here, this one, terminating decimal. The terminating decimal when we will get when in case of division, when the remainder becomes 0, then we have to stop the division, and in that case we will get the decimal as terminating decimal. So here you see, take one rational number 7 by 8. Now divide 7 by 8. Here the division is shown here. Now after dividing, you check by yourself in your copy. So after dividing, you are see the remainder is coming 0. Here numerator is 7, denominator is 8. So now as we cannot divide 7 by 8, so we are putting one decimal. After putting the decimal, on the basis of the decimal, I can put 1 0. One extra 0 is allowed for this decimal point. So this 7 is becoming a 17. Now I can divide. So in that way, I am continuing the division in terms of the decimal where the quotient is coming a decimal number, and finally I am getting 0. So the value of 7 by 8 in decimal form is 0.875. So as the remainder is coming 0, that means our process is stopped. In that case, the decimal value of that rational number is called here terminating decimal. Terminating means it is stopped. This is the meaning of terminating. So this is the first type of decimal for rational number is here terminating decimal. That means when the remainder becomes 0. Now another type of decimal for rational number is here non-terminating and repeating. Repeating means you can use another word for repeating, that is your recurring. So another type of decimal expansion for rational number is non-terminating and repeating or recurring decimal. And when we get this type of decimal, when the remainder never becomes 0, so we go on dividing with the help of decimal point. Now if the remainder is never coming 0, that means division is going non-stop, it will not finish. In that type of divisions, the value of the rational number is called here non-terminating and repeating within bracket or recurring. So for example, you see here I have taken two examples, 1 by 3 and 1 by 7. The first you divide 1 by 3. As 1 is smaller than 3 divisor, so we have to put one decimal point here. With the help of decimal point, 1 0 is allowed with this 1. So now it will go 3 times 3 3 is 9. Then remainder after minus remainder is coming 1. Then again with the help of this decimal point, 1 0 is allowed in each and every step. So remainder 1 is coming with the help of decimal point, put 1 0. Again it will go 3 times. Again 9 is there, again minus is 1 is coming, the previous step also remainder 1 coming, next step also remainder 1 coming. Again with the help of decimal point 1 0 allowed here, again divide by 3, it will go 3 times. 9 is coming, again remainder is 1 is coming. See, same procedure is continuing, so it will not stop. It will not stop ever. So the decimal will continue like this, 0.3333 like this. As the remainder never becomes 0, and here also it is clear that the remainder will never become 0, then the decimal value of 1 by 3 is 0.333. And I have to put here dot dot dot. These dots will represent that the decimal is not stopping. It will go up to infinity. 333 will go, it will never stop here. So this type of decimal is called your non-terminating and repeating decimal. Okay, non-terminating means it is not stopping. It will not stop ever. That is called non-terminating. But what the meaning of repeating or recurring? Repeating means in the decimal value of the quotient, one single digit may continue, may repeat, single digit may repeat, or sometime a block of digits will repeat. So that's why the decimal is called non-terminating and repeating decimal. So here you see in this decimal quotient, one digit, that is 3, is repeating here. 3 is coming non-stop. 3 3 3 will go like that only. 3 3 3. So in this decimal, one single digit is repeating. That digit is here 3. That's why this decimal is non-terminating and repeating, because here the single digit 3 is repeating. That's why when you write in a short this non-terminating repeating decimal, then you put bar on the repeating digit. As the repeating digit is 3, so you put a 0.3 on the top of 3, you put a bar, and this bar represents that the digit 3 is repeating in this decimal value. So this type of decimal is called non-terminating and repeating decimal. One more example is that 1 by 7. So next is a 1 by 7. So numerator is 1, denominator is 7, so divide 1 by 7. As 1 is less than 7, to put one decimal point with the help of decimal point, 1 0 allowed here with 1. Now it is 10 and its divisor is 7. So divide 10 by 7, it will go 1 time. The 7 1 the 7, the remainder is 3. Now for this decimal point 1 0 allowed in each and every step, put 0, it will become 30. Now 7 will go 4 times, 7 4 is 28, the remainder 2. Then put 0, 7 2 is 14, minus 6, put 0. Then 67 8 is 56, minus 4 is coming, put 1 0, 40. The 7 will go 5 times, 7 5 is 35. Then 5 is coming, put 1 0, 50. Again 7 will go 7 times, 7 7 is 49. Then minus 1. Now see, earlier we are having this one dividend, here 1, and with the help of decimal point we made it 10. Now here also see, after minus 1 is coming, and with the help of the decimal point we are putting 1 0, then again 10 is coming here. So here, from here starts repeating. As earlier it was 10, again you are getting 10, means again whatever you divide, again same steps, same previous steps, all the steps again continue from here. That's why I have written here, from here starts repeating steps. So from here you see the decimals you are getting, again 10 is coming. Previous starting also 10 was there, now 10 is coming. Again you go on dividing, again previous steps I now repeat here. So again divide by 7, again it will go 1 time. Earlier also it was 1. Now repeating here, 7 1 is 7, 3 is coming, 30. Now again 30 divided by 7, that is 4 times. 4 here also 4, so 28. Minus 2 will come here, it will become again 20. Then again it will go 2 times already here. So see, this block again starts repeating from here, and it will not, that means it will not stop, because same thing starts repeating here. It will go repeating and repeating and repeating, and it will never stops. So there is no chance of getting the remainder 0. So the decimal is non-terminating decimal we will get here. Now apart from that, the decimal non-terminating, but there you find one block of repeating digits. See this block containing this in the decimal part, containing the digits 1, 4, 2, 8, 5, 7. This is a block of digits which will keep on repeating again from here. So this is a non-terminating non-terminating decimal and repeating also or recurring, because you are finding one block of digits which is repeating. So this type of decimal is called non-terminating and repeating decimal, or non-terminating and recurring decimals. So here the value is 1 by 7 is 0.142857114 dot dot dot, because it is non-terminating. Now here you see this block is repeating. Okay, this block is repeating. Therefore, on this repeating block, put one bar here. So this block will show that this is a non-terminating decimal, and this block will keep on repeating in this non-terminating decimal. So this is example of non-terminating and repeating decimal. Okay, so you have understood that a rational number will have two types of decimals. One decimal is called terminating decimal when the remainder is coming 0, and another decimal when the remainder never comes 0, and then in that case the decimal is called non-terminating and repeating decimal, because in that non-terminating decimal value we will have one single digit may repeat, or any block of 2 or more than 2 digits will repeat. So those type of decimals are called non-terminating and repeating decimals. Very good. The next I'll give you the definition of irrational numbers in terms of the decimal expansions. The last class we got the definitions of irrational numbers. Today we will again define this irrational numbers in terms of its decimal expansions. The next you write irrational numbers. So definition of irrational numbers in terms of the decimal expansions. The numbers which have non-terminating and non-repeating decimals are called irrational numbers. That means the decimal number must be non-terminating, means dot 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 will be there. That dots will represent that it is non-terminating, and non-repeating, that means no single digits will repeat, or not a block of digits will repeat. You cannot find any repeating block of digits in those decimals, and those type of decimals are called irrational numbers. For example, you see irrational numbers 2.3137425938263339 dot dot dot. This dot dot means it is a non-terminating decimal. But can you find any repeating digit, single repeating digits, or can you find any block of repeating digits? No. Here you see this decimal part. If you observe the decimal part, you can't say what digit will come after this 9, because the decimal numbers, the digits are in the decimal part, it is coming in an unruly way. They are not maintaining any proper order, so we can't say what will come after 9. But here you see, if you observe this decimal part 142857, again it is come 14. That means after this again it starts repeating here. 1 is there, 1 here, 4 is there, 4 here. So after 4 what will come? 2 will come. I can write 2 because from here the repeating block is clear. After 4 I can write 2. After 2 I can write here 8 because this block will repeat. But here I have not observed any pattern from which I can say that any single digit is repeating or any block of digits is repeating. You cannot find from these decimal parts. So this is a decimal which is non-terminating and non-repeating decimals. So this is the example of your irrational numbers. And one standard example I'll show you how to form the decimals for irrational numbers. That means how to form non-terminating and non-repeating decimals. There is one standard procedure. I'll show it. So you can, before decimal point, you can write anything. I'll write here 0, then put a decimal point, then after decimal point use only 2 digits. I'm using 3 and 5. After decimal point use only 2 digits. Okay, then after that keep one digit fixed and keep one digit increasing by 1. So suppose here I am fixing 3. So as it is non-terminating, so it will go non-stop, dot dot should be there, but there should not be any repeating digits or no block of repeating digits. So here 3 is there and 5 I am using. Then how to write non-terminating and non-repeating decimals here with the help of these 2 digits? So 3 I will fix here and 5 I will keep on increasing. So here again single, here single 3, so you also add single 3, but number of this 5 I will keep on increasing. Here single 5, then here I will put double 5. Again I am fixing the number of 3, as 3 is single 3, here also I am putting single 3. Again I will put single 3 and keep the increasing the number of 5. Here number 5 is 1, here number 5 is 2, then here I will put 3 5s. 5. Again I'll keep 3 here, single 3 only. Then I'll put 4 5s here. Again I'll put single 3 here. Then dot dot dot. This is the standard example of irrational numbers using the only 2 digits. So here is a dots are there. That means it is irrational numbers. Because you see this is non-terminating. And also you see you can't find any digits repeating. You cannot say that 3 is repeating. If 3 is repeating, then 3 must come non-stop, 3 3 3 3 3 3 like that. But 3 is not coming non-stop, so 3 is not repeating. So even you cannot say that 3 and 5 this block is repeating, because if 3 and 5 is repeating, then 3 5 3 5 3 5 3 5 must come here. So this pattern, it is maintaining a pattern, but you cannot say that any digit or any block of digits is repeating here. So this is a non-repeating decimals, and also dots are there, so it is non-terminating. So this is an example of non-terminating and non-repeating. That is, it is an example of irrational numbers. One more example you see, 5 point I'll put here 2 and 7. After decimal point, before decimal point anything you can put, no matter. After decimal point I am putting 2 digits. Now one digit will remain single throughout the pattern, but another digit I'll keep, number of another digit I'll keep on increasing. So here I'll only use single 7s throughout the decimals, single 7, but I'll keep on increasing the number of 2s in the decimal values. So 2 single here, now I'll put double 2s here, then 7 single 7 only, then I'll put 3 2s, 3, then 7 here single, now 4 2s, then 7. And this is an example of non-terminating and non-repeating decimal. So these are the examples of irrational numbers. And also you see root 2. We know that the numbers containing root over sign are always taken as irrational numbers. Here 2 is containing root over sign, so this root 2 is irrational number. But one thing I think you have remembered, 4 is contained root over. So do you think this is a irrational number? No, because root 4 value is here 2, which is purely a rational number. Rational number. But here 2 square root of 2 we cannot find. Exact square root of 2 cannot be obtained here. So root 2 is your irrational number. And see the decimal value of root 2. Root 2 decimal value. You can also check the root 2 values in the internet. You can check root 2 value, you can check root 3, you can check root 5 like that. So root 2 values I have written here. This is 1.41421356 237. See, it is going up to infinity. It will not stop. So dots are there. That means this is non-terminating decimal. And one thing you see, no digit is repeating here. No single digit repeating, or you cannot find any block of digits which is repeating here. So this decimal is an example of non-terminating and non-repeating decimal. So this is called your irrational number, this type of decimal. That's why this root 2 is called your irrational number. Now see pi, which normally we use in our circle chapter when we solve the problems based on area of a circle, or when we solve the circumference of a circle. We use the formulas. For circumference we use the formula twice pi r of a circle, and when we find the area of a circle we use the formula pi r square. So pi, when we solve the problems we use the value of pi as 22/7, but actually pi value is not 22/7. Simply we assume pi is 22/7 to solve our problems, but pi value is not exactly 22/7. Pi, if you check the decimal value of pi, so decimal value of pi, this is the decimal value of pi. So see dots are there, that means it is non-terminating. And also you see the decimal part, no single digit, or you cannot find any block of digits which is repeating. You cannot find any digit repeating block here. So this decimal example of non-terminating and non-repeating decimal. So this decimal is called your irrational number. So this pi also it is called irrational numbers. So always remember, pi value is not actually 22/7, but for solving our numerical problems we always use pi value is 22/7, but actually pi is an irrational number. So now I'll give some questions. As you know that between two rational numbers there are infinite rational numbers. In the same way, in between of two rational numbers there are infinite irrational numbers. So based on this I'll give you some questions. You do it. Okay, question is that find three rational numbers and three irrational numbers between 1/3 and 1/5 and 1/2. So here in between 1/3 and 1/2 you have to find three rationals and three irrationals. Okay, rationals, how to find between two rationals? You got the procedure earlier classes, earlier videos. Now today I will show the answers in the decimal form. I will write three irrational numbers between these two in decimal form, and I will write three irrational numbers in decimal form. In writing decimal form it is very easy. So see, so therefore you write 1/3, you write in decimal 0.3333 like this, and 1/2 it is 0.5. So for these two rational numbers 1/3 and 1/2 I have given their decimal values. One is non-terminating repeating, other is terminating decimal. Okay, now between these two you have to write three rational numbers, and between these two you have to write three irrational numbers. So you write here, therefore three rational numbers are, in between these two you can write 0.4. You can write this is a rational number, this is a rational number, because you see this is a terminating decimal. The terminating decimals are rational numbers only. Then you can write 0.41. This decimal is also terminating decimal. So this is example of rational numbers, because rational numbers have two types of decimal expansion. One is terminating, another is non-terminating and repeating. So if it is terminating, then also it is a rational number. This decimal terminating, this is a rational number. And also you see these two decimals are lying between these two. The two rational numbers I have written, and one more you write 0.42, this decimal lying between these two, and it is also terminating decimal. So this is example of rational numbers. Now I let three irrational numbers between these two. So those three irrational numbers in decimal, those should be non-terminating and non-repeating, and they must lie between these two. So right here, three irrational numbers are 0. See, the decimals must lie between these two. The 0.41 you write this decimal lying between these two. Now this you have to make it irrational numbers, so this decimal should be non-terminating and non-repeating. So with the help of two digits after decimal point, how to make it non-terminating and non-repeating decimal? One number of digits keep fixed and one number of digits keep on increasing. So suppose 4 you keep fixed, you repeat 4 single time, but you use 1 by increasing its number. So 4 1, then again single 4 I'll put here. Now increase the number of 1, I'll put 2 ones here, then single 4, now I'll put 3 ones here, now 4, then 4 ones here, now 4 dot dot. So this is a decimal which is non-terminating and non-repeating, and it is lying between these two. So this is example of irrational number. Understood? It's very interesting and very easy. The next you write 4 2, this is lying between these two rational numbers. Then one if number is fixed, one number you keep on increasing, 4 will keep fixed, 2 number increasing, double 2, then 4 single, then triple 2, 4 single, then 4 2s here, then 4 single. This is irrational number, non-terminating, non-repeating. One more 0.43, then 433, then 4333, then 43333, and 4 dot dot. This is example of non-terminating, non-repeating decimal. So these are the examples of irrational numbers, and these are examples of rational numbers. So in terms of decimal expansions, how to define rational and irrational numbers? The definition of rational and irrational in terms of decimal expansion is that first are rational numbers. The numbers having terminating decimal or non-terminating and repeating decimal are called rational numbers. Now for irrational numbers, the numbers having non-terminating and non-repeating decimals are called irrational numbers. Okay, this much for today. Hope you have understood. If any doubt, please discuss with me, and based on this topic I'll give you few examples to solve it. Thank you very much, and next class I'll solve few problems from the exercise 1.3, And few questions from exercise 1.3 I'll give you homework also, and few questions I'll solve it. Okay, thank you very much.